Welcome back to the highlights from the Minisymposia at the PASC 2025 conference. I'm joined here by Abraham Leviton from the Paul Scherrer Institute, and you just gave an exciting Minisymposium, Ptychographic X-ray tomography for non-destructive imaging of complex nanoscale structure.
That's right. Yeah.
Tell us more about it. I've done normal tomography on biological samples, but this is in another league, right?
Yeah, so we were talking about a method called Ptychographic X-ray tomography, where the individual images that we use to synthesize these wonderful three-dimensional images of all sorts of different structures actually come through a very computationally intensive process. We collect data that looks very, very different from the images we produce in the end of the day. And it's becoming a much, much bigger problem, the challenge of actually finding enough computational resources to reconstruct all the images that you collect in these kinds of experiments, which we do all the time at the Paul Scherrer Institute nearby and at many places around the world. So we had an interesting collection of speakers who are at instruments that are really starting to face this problem as the brightness of the instruments that they're using gets brighter and brighter.
All right, so that sounds like you're in the right conference then.
Yeah.
What more specifically did you talk about in the symposium?
Yeah, so we had the folks who were speaking in the symposium. There were really 4 different experts in developing the algorithms that transform the raw data that we collect into the final images. And they were presenting on a whole range of different topics, specifically with regard to how do you make these algorithms more efficient? How do you make these algorithms take advantage of the kinds of compute power that exists today? And also, how do you figure out how much compute power you need as you take more and more and more data to sort of dig your way out from this data hole that people wind up in.
So how much data do you typically have in one experimenter?
Well, it depends, but one of the presenters was talking about a 300 terabyte experiment that they had recently worked on, and that was, I think, probably a day or 2 of data collection, and these instruments can run, more
So that's something, are you using machine learning methods in this field too then, or?
Well, this is an interesting question to ask, actually, because, again, a different one of the presenters had pointed out a major problem we have. We have machine learning methods, and they don't work very well. And so there's kind of a need at this very moment for people to come in and develop better methods for us, because at the moment, the standard methods far outperform what people can do with machine learning.
So that sounds like an exciting, middle area between that you can use computers, but there is potential new development in computers that would rely on data, but you certainly have the data sets here too, right? So it's like possibly an area where you want to get together and have application experts spend several years on these problems.
Absolutely, yeah.
So what's the next step here? Did you learn anything here? Any call to action, what we need to do to make this work?
Yeah, so what we really learned coming out of this conference, or this mini symposium, is that the folks that I work with, we face one set of challenges, which is we don't have enough computers and we have way too much data. And what we found is that everybody has not enough computers and way too much data. And so the call to action is, please get us some more computers, get us some more experts who know how to write code for these computers.
I heard there is this new computer in Lugano in Switzerland out, right?
We're very excited for that to come online and for us to start doing some processing there.
Okay, so the second we let you on that computer, it's going to be full.
We're going to take over 80 GPUs continuously.
That's the reason why we bought it.
Yes.
Great. Thank you so much for joining me, Abraham.
Yeah, wonderful.
Great to see you, and thank you.